Rolle's theorem says that if there is a function that is continuous on a closed interval a, b, and that function is differentiable on the open interval a, b, then if f of a is equal to f of b, then there is a number c such that the derivative of c is equal to 0. Now it looks more complicated than this. Actually something very simple. What it's saying is that if I have 2 points and they have the same y value, so they are the same height from each other on a graph, and it's a function, so therefore there's a line, they're connected, and there are no holes in that line, and it's just like a regular polynomial, then at some point the derivative between these 2 points, the derivative has to be equal to 0. And this is best understood just by looking at the different possibilities that can happen. So if I've got 2 points, it's continuous on a closed interval, so it goes from a to b. It's differentiable, there are no holes in this graph. It's just some polynomial, just to keep it simple. It doesn't have to be a polynomial, but I'm just going to say that it is. Let's look at what could possibly happen. So the first and the easiest thing that could happen is that it could just be a straight line, in which case the derivative would be 0 constantly. So there's no rate of change. So that's very simple. And let me go to these other ones first. These, I probably should have rearranged them, but let's suppose that it just goes up first, and then it must eventually come back to b. So it goes up and then it goes to b. Well, then there is going to be a point up here where the derivative will equal 0. And same thing if it goes below. At some point the derivative will be equal to 0. And if it goes up and below, then there will be more than one place where it's equal to 0. So what these pictures are trying to illustrate is that if I've got 2 points that are connected and they're going to be of the same height, then at some point the derivative will be equal to 0. And the best way to really understand this is just try to draw a line between a and b that are of the same height on a graph where the derivative wouldn't be equal to 0.